Your biology class is going to have a 13-question multiple choice exam. In an effort to reward students that faithfully attend class, the prof tells the class that 3 questions will have the answer A, 2 questions will have a B, 1 a C, 3 a D, and 4 questions will have an answer E. How many ways can the students use this information and answer the exam? If we think about this, one way of answering this exam is, well, those are 3 A's, 2 B's, a C, 3 D's, and our 4 E's. If I wanted another way of answering the exam, I would shuffle the letters around. Now, once I think about shuffling letters, I remember this as distinct rearrangements. So the answer to this would be 13 factorial over the repeats, 3 factorial, 2 factorial, 3 factorial, and 4 factorial. Now I could have also worked this problem by saying, well, there's 3 A's, 2 B's, 1 C, 3 D's, and 4 E's. I can view this problem as saying, okay, well, I have 13 questions. I need to pick 3 of them to be the letter A. Those 3 questions, I'm not concerned about the order, so it's a combination. 13, choose 3. 3 questions are now gone. There are now 10 questions left. I need 2 of them to be the letter B. Of the 8 remaining questions, I need 1 for the C. Of the 7 remaining questions, I need 3 for the D. And last but not least, of the 4 remaining, I need 4 for the letter E. Now, this procedure doesn't matter which letter you put first. In other words, I could have started this off with B's, C's, D's, E's, and then picked A's, as long as I followed that pattern. So here we have 2 different answers for the same problem. So you have a CD collection that doesn't have any duplicates in it. You want to place them all on the shelf. How many ways is this possible if CDs by the same artist are grouped together? So if you look at the CDs from Brian White, there's 4 of them. So if they came first on the shelf, that would be a 4 factorial. George Strait, you had 7 of those, so times 7 factorial. Savage Garden, there's 2 of those, so 2 factorial. And the Coors is 3 factorial. Now that's placing those CDs on the shelf, but in this particular order. You have the Brian White, George, Savage Garden, and then the Coors all in that row. Now we want to consider shuffling up this order. In other words, moving the artist around. Since we have 4 different artists, we need to take this answer and multiply by 4 factorial. In part B, when we want to grab 6 of the CDs, we want to know how many ways can we get exactly 3 of George's or exactly 3 of Brian White's. Now the key word is or. Now remember, or comes back to this formula. Number of A union B is the number of A plus the number of B minus the number of the intersection. So I want to look at exactly 3 from George Strait. So that's going to be the combination 7 choose 3. Now I still need 3 more CDs to fill out the rest of the group. So of the remaining CDs, well, we had 4 from Brian, 2 from Savage, and 3 from the Coors. So there's 9 of those, and we need 3. So what we have is, this is George Strait, and these are the others. Plus, now we want to do the other group, exactly 3 of Brian White's. So combination, 4 choose 3 of the remaining others. So from George Strait, Savage Garden, and the Coors, there's 12 of them. we need 3. So notice both of these are picking 6 CDs because we're selecting 6 of them. We're not concerned about the order because we're just grabbing out those CDs. But we also have the possibility of having overlap. So we need to subtract off the overlap. In other words, in this problem, can we get 3 of George Strait and 3 of Brian White at the same time? The answer is yes. So we need to subtract off the combination 7 choose 3 times the combination 4 choose 3. In how many ways can you get a license plate consisting of 4 letters and 2 digits in any order with no digit or letter repeated? Now if we think about this, our 4 letters and 2 digits, there's an example of this type of license plate. We know, well, for letters, there's 26 times 25 times 24 times 23, or another way of writing that is permutation 26 choose 4. We want these in a specific order. We don't want repeats. Our digits are 10 times 9, or permutation 10 choose 2. And this gives us an example of a license plate that meets that requirement. Now, we want our digits and letters to be of any order. So in other words, I take this license plate here that I have 4 L's followed by 2 D's. In other words, it's 4 letters followed by 2 digits. And I want to consider, well, how many ways can I shuffle those around? In other words, there's another way of rewriting this. So if I did letter, digit, letter, letter, digit, letter, I would still have a 26, 25, 24, 23 for my letters, and then 10 times 9 for the digits. So I need to take this answer here, whether I write it with permutations or the multiplication principle, and multiply it by how many ways to rearrange. Well, that is 6 factorial divided by 4 factorial, 2 factorial. And so that will give me the number of ways of creating this license plate. Now there's an alternate way of solving this problem, is if we sort of reverse how we approach it. I could come in and say combination 26 choose 4 and the combination 10 choose 2. Now we know the combination 26 choose 4 picks 4 letters out of all 26 letters, but combination means order is not important. So in other words, it's like picking the 4 letters and holding them in our hand. The combination 10 choose 2 picks the 2 digits and holds them in our hand. So in our hand we have 6 items. Now we want to know is how many license plates can we make out of those 6 items. So then I take this and I multiply by 6 factorial. The first bit here, in other words, picks the letters, and the digits, and this bit at the end, the 6 factorial, puts it in the row. So in other words, there's 2 ways to solve this problem depending on how you approach the problem.